Top 25 Manufacturing Engineer Interview Questions and Answers. Whether you're a fresh graduate or an experienced professional preparing for your next big interview, this video will help you understand exactly what hiring managers are looking for. We'll go through technical, situational, and behavioral questions, each followed by a clear, detailed answer to help you stand out from other candidates. So grab a notepad, stay focused, and let's get you interview ready. 1. Tell me about yourself. This question helps interviewers assess your background and communication skills. Start by highlighting your educational background in mechanical or industrial engineering. Mention your key areas of expertise such as process optimization, lean manufacturing, or product quality improvement. Briefly talk about your past experience in design, production, or process engineering. Then transition to what makes you passionate about manufacturing, perhaps your interest in efficiency, technology, or problem solving. End by connecting your background to the company's goals. Example: I'm passionate about improving production systems and reducing waste through lean methods. At my previous job, I helped reduce cycle time by 15%. I'm excited about this role because it aligns with my goal to contribute to innovative, high-quality manufacturing processes. 2. What are the main responsibilities of a manufacturing engineer? A manufacturing engineer focuses on designing, implementing, and improving manufacturing processes to ensure efficiency, safety, and product quality. Responsibilities include analyzing workflows, developing standard operating procedures, managing automation systems, and maintaining production equipment. They also collaborate with product design teams to ensure manufacturability and cost effectiveness. Additionally, manufacturing engineers play a key role in quality control, waste reduction, and continuous improvement initiatives using tools like Lean Six Sigma. In short, their mission is to streamline production while maintaining high standards and minimizing costs. You can mention: a manufacturing engineer bridges design and production, ensuring that what's designed can be efficiently and reliably manufactured. 3. What do you understand by lean manufacturing? Lean manufacturing is a systematic approach to reducing waste in production processes while maximizing value to the customer. It focuses on eliminating activities that do not add value, such as overproduction, waiting time, excess inventory, or unnecessary motion. Lean tools include 5S, Kaizen, Kanban, Value Stream Mapping, and Just-in-Time, JIT. The goal is to create smooth, efficient processes that use fewer resources but deliver higher quality. You could say: in my previous role, I implemented lean principles to improve workflow and reduced downtime by 20%. Lean manufacturing isn't just about saving costs, it's about creating a culture of continuous improvement and empowering employees to spot inefficiencies. 4. Explain Six Sigma and its importance in manufacturing. Six Sigma is a data-driven methodology focused on minimizing defects and improving quality by controlling process variability. It uses the DMAIC framework: define, measure, analyze, improve, and control. Six Sigma aims for near-perfect performance with a defect rate of fewer than 3.4 defects per million opportunities. In manufacturing, it helps identify root causes of process failures, optimize production efficiency, and reduce waste. For example, at my last job, I used Six Sigma tools to analyze scrap data and found the main cause was improper machine calibration. By addressing it, we cut scrap rates by 25%. Understanding Six Sigma demonstrates your ability to use statistical analysis and structured problem solving to achieve measurable improvements. 5. How do you ensure quality in the manufacturing process? Ensuring quality involves both preventive and corrective actions. I focus on process control, standardized procedures, and continuous monitoring. I use quality management systems, QMS, such as ISO 9001 to ensure compliance. Regular inspections, SPC, statistical process control, and feedback loops are essential to detect variations early. Collaboration with operators and technicians also ensures everyone understands the quality standards. For example, I established a quality checkpoint at each stage of production, reducing rework by 30%. The goal is always proactive quality control, preventing defects before they occur, rather than fixing them afterward. 6. What is the difference between product design and process design? Product design focuses on creating the product itself, its features, functionality, and user requirements. Product design involves engineers and designers determining what the product should do, while process design determines the best manufacturing methods, materials, and machinery. For example, a product designer may specify a part's shape, but a manufacturing engineer decides whether to use CNC machining or injection molding to make it. You could answer: I've worked closely with design teams to ensure products are both innovative and easy to manufacture. Good process design ensures scalability, cost control, and consistent quality. 7. What tools or software do you use for manufacturing process design? Manufacturing engineers rely on various tools and software to design, simulate, and improve processes. Common CAD tools include SolidWorks, AutoCAD, and CATIA for 3D modeling. For process simulation and analysis, tools like Siemens NX, ANSYS, and MATLAB are used. ERP systems such as SAP or Oracle help integrate production planning with business operations. In addition, statistical software like Minitab supports data analysis for quality control. You might say, I use SolidWorks for fixture design and Minitab for analyzing process capability. In my last project, I simulated assembly sequences in AutoCAD to optimize line layout, cutting setup time by 12%. Employers look for candidates who can combine technical know-how with practical problem solving, using software as a means to improve efficiency and decision-making. 8. What is process validation, and why is it important? Process validation ensures that a manufacturing process consistently produces products meeting predefined quality standards. It involves 3 key stages: installation qualification, IQ, operational qualification, OQ, and performance qualification, PQ. This practice is critical in industries like automotive, aerospace, and medical devices, where precision and consistency are vital. It proves that equipment, methods, and systems function as intended. You can say, in my previous role, I conducted process validation for a new assembly line. By testing parameters and verifying repeatability, we ensured the process met quality standards before full-scale production. Validation minimizes defects, ensures compliance with regulations, and builds confidence in long-term production reliability. 9. Describe a time when you improved a manufacturing process. A great answer highlights measurable results. For instance, at my previous company, our assembly line was facing frequent delays due to material handling inefficiencies. I analyzed the workflow using value stream mapping and identified redundant steps. After reconfiguring workstation layouts and introducing a Kanban system, we reduced idle time by 25% and increased throughput by 18%. This shows that you can identify root causes and lead improvement initiatives. Always include quantifiable results like cost savings, defect reduction, or production time improvement. End with the lesson learned that continuous improvement requires collaboration between engineering, quality, and production teams. 10. What is your experience with automation and robotics in manufacturing? Automation is transforming modern manufacturing. As a manufacturing engineer, you might explain your hands-on experience. I've worked with robotic arms, PLC-controlled systems, and automated assembly lines to improve consistency and speed. At my last job, I helped integrate a robotic welding station that increased output by 30% while improving weld quality. Discuss technologies like SCADA systems, vision inspection, or IoT-based monitoring if relevant. Emphasize the balance between automation and human oversight. Mention that automation isn't just about replacing labor, it's about enhancing safety, precision, and process control while allowing operators to focus on higher-value tasks. 11. How do you handle tight deadlines or production pressures? Manufacturing environments often face strict deadlines. Show your ability to stay organized and calm. You can answer, I handle pressure by prioritizing tasks, maintaining open communication with my team, and relying on data-driven decisions. During a recent production ramp-up, we faced equipment downtime just before a deadline. I quickly coordinated with maintenance, implemented temporary rerouting, and met our target on time. Stress time management, collaboration, and proactive problem-solving. Employers want candidates who stay focused under pressure and can adapt without compromising quality or safety. 12. What is your understanding of the 5S methodology? 5S stands for sort, set in order, shine, standardize, and sustain, a cornerstone of lean manufacturing. It's about maintaining workplace organization and efficiency. You might say, I implemented 5S principles in our assembly area by labeling tools, reorganizing workstations, and establishing cleaning schedules. This improved tool retrieval time and boosted productivity by 10%. Explain that 5S helps create a safer, more efficient environment, reduces waste, and instills discipline among employees. When consistently followed, it enhances morale and supports continuous improvement initiatives. 13. How do you reduce production costs without compromising quality? Cost reduction isn't just about cutting corners, it's about improving efficiency. Start by saying, I focus on optimizing processes, minimizing waste, and improving machine utilization. For example, I introduced preventive maintenance to reduce equipment breakdowns and material losses. Discuss using tools like root cause analysis, lean methods, and supplier negotiations to manage costs. You can also mention energy-saving initiatives or design for manufacturing, DFM, techniques. Emphasize maintaining quality by using data-driven decisions and risk assessment before any cost-cutting measures. 14. What is a bill of materials, BOM, and why is it important? A bill of materials, BOM, is a detailed list of all components, subassemblies, and raw materials required to manufacture a product. It serves as a blueprint for production, ensuring accuracy and consistency. You can say, the BOM links engineering, production, and purchasing teams, helping prevent shortages and maintain traceability. A well-structured BOM also simplifies maintenance, cost estimation, and product lifecycle management. Highlight your experience managing or updating BOMs in ERP systems like SAP or Oracle, emphasizing accuracy and revision control. Without a reliable BOM, production errors and delays are inevitable. 15. What safety measures do you follow in the workplace? Safety is a manufacturing engineer's top priority. You can answer, I believe in proactive safety management, conducting regular risk assessments, training employees on PPE usage, and ensuring machine guards are in place. Reference frameworks like OSHA standards or ISO 45001. Describe an example. I introduced a safety checklist before each shift, reducing near-miss incidents by 40%. Show that you prioritize both physical and procedural safety, from ergonomics and ventilation to hazard communication and emergency response plans. Employers value candidates who integrate safety into every stage of production. 16. How do you handle equipment breakdowns or maintenance issues? Demonstrate problem solving and teamwork. When equipment breaks down, I first ensure safety protocols are followed, then coordinate with the maintenance team to diagnose the issue. I analyze root causes to prevent recurrence. Share a specific example, like, we had frequent conveyor stoppages due to sensor misalignment. I collaborated with maintenance to redesign sensor mounts, reducing downtime by 50%. Highlight preventive maintenance and predictive analytics, showing that you understand how data can forecast issues before they cause disruptions. 17. What do you understand by continuous improvement? Continuous improvement, or Kaizen, is the ongoing effort to enhance processes, products, and services. It involves everyone, from top management to operators. Say, I believe improvement comes from small, consistent changes. In my last job, I implemented operator feedback sessions and used their input to reduce unnecessary movements, saving 10 minutes per assembly. Mention tools like PDCA, Plan, Do, Check, Act, Lean, or Six Sigma. Continuous improvement fosters innovation, quality, and a culture of accountability in manufacturing environments. 18. How do you approach training new employees on processes? Explain your structured training approach. I start by assessing skill levels and providing clear, step-by-step instructions using visual aids like SOPs and process flowcharts. I also conduct on-the-job demonstrations and safety briefings. Stress patience and feedback. Example. When onboarding new operators, I developed a modular training guide that reduced errors during the first month by 20%. Mention your belief in mentorship and periodic evaluation to ensure consistent performance. Effective training boosts productivity, morale, and long-term process stability. 19. What is root cause analysis, and how do you apply it? Root cause analysis, RCA, identifies the underlying cause of a problem instead of just treating its symptoms. It uses tools like the 5 Whys, Fishbone, Ishikawa diagram, and Pareto analysis. By redesigning storage procedures, we eliminated 80% of defects. Emphasize your logical approach and teamwork in solving problems. RCA ensures lasting solutions and reduces rework or waste in manufacturing. 20. What key performance indicators, KPIs, do you monitor? Manufacturing engineers track KPIs such as OEE, overall equipment effectiveness, defect rate, production yield, cycle time, and downtime. You can say, I monitor OEE to assess equipment efficiency and track first-pass yield to gauge product quality. Include an example. By analyzing downtime data, I identified maintenance scheduling gaps that improved OEE by 10%. Mention cost per unit, scrap rate, and on-time delivery as well. KPIs help ensure continuous improvement and align production goals with business objectives. 21. How do you deal with conflicts on the production floor? Conflicts are common when working in fast-paced environments. Show emotional intelligence. I listen to both sides calmly, identify the root of the disagreement, and focus on facts rather than emotions. Provide an example. When production and maintenance teams clashed over machine downtime, I mediated a meeting and clarified scheduling priorities. We agreed on better communication through shared dashboards. Stress empathy, communication, and fairness, qualities that build trust and teamwork under pressure. 22. What is design for manufacturability, DFM? Design for manufacturability, DFM, is an engineering approach that ensures products are easy and cost-effective to manufacture. It involves early collaboration between design and manufacturing teams to minimize complexity, reduce costs, and improve quality. Example. I worked with a design team to simplify a component's geometry, reducing machining time by 15% without affecting performance. Mention that DFM considers factors like material choice, tolerances, assembly ease, and automation compatibility. It bridges innovation and practicality, ensuring designs move smoothly from concept to production. 23. How do you ensure environmental sustainability in manufacturing? Modern manufacturing focuses heavily on eco-efficiency. You could say, I integrate sustainable practices like reducing material waste, optimizing energy usage, and reusing process water where possible. Mention ISO 14001 standards or recycling initiatives. For example, at my previous job, I introduced scrap metal recycling that saved 5 tons of waste annually. Emphasize balancing productivity with responsibility, selecting energy-efficient equipment and eco-friendly materials wherever feasible. Sustainability isn't just ethical, it enhances brand reputation and reduces costs long-term. 24. Describe a project you led from start to finish. Pick a measurable, successful project. I led a project to automate the packaging line. I analyzed the process, selected suitable robots, coordinated with vendors, and oversaw installation. The result was a 35% throughput increase and a 20% labor reduction. Emphasize leadership, communication, and accountability. Explain how you manage budgets, schedules, and cross-functional teams. Conclude with lessons learned, such as the importance of risk assessment and involving operators early in the process. 25. Why should we hire you as a manufacturing engineer? This is your chance to summarize your strengths. My experience in lean manufacturing, automation, and data analysis has consistently led to measurable results, from reducing waste to boosting efficiency. I'm a proactive communicator who thrives in collaborative environments and believes in continuous improvement. I'm confident my skills and mindset align perfectly with your company's vision for innovation, quality, and operational excellence. Keep your tone confident yet humble. Thanks for watching. If you found these top 25 manufacturing engineer interview questions and answers helpful, don't forget to like, share, and subscribe for more job interview preparation videos. Remember, preparation and confidence make all the difference. So study these questions carefully, practice your responses, and walk into your interview ready to impress. Good luck, you've got this.